In the Section 6.6 problems that accompany Section 6.4, we're going to be looking at solving polynomial equations where there's a number in front of the x squared term. So this equation may not look like one of those initially, but remember it needs to follow these two rules, be set equal to 0 and be made up only of factors. So by the time I use a little algebra to rearrange this, distributing the x onto the 4x and the negative 11, and moving the 3 to the other side, I'm left with a polynomial that has a 4 in front of our x squared term. So I want to take a minute here to show you an alternative way that you can do factoring. When you've got a polynomial that has a leading coefficient, having a place to organize what your potential factors are can be a good idea. So I stole this particular technique from Stephanie, a student I had in my class last semester. She takes the outside terms, the 4 and the negative 3, and multiplies those together and puts those at the top of a big letter X. And my whiteout I put on this is not letting this write very well. So the product of these two goes here, and the sum that you're aiming for, that negative 11, goes down here. So we're looking for something that will multiply to negative 12 that adds to negative 11. And the pair of factors that is negative 12 and positive 1. Now here's the part where most students are going to make a mistake if they're going to make one. These are not the factors that go in your binomial the way that they were when you didn't have a leading coefficient. All these numbers are doing is telling you that you need to take this middle term and break it up into two pieces. So the 4x squared is going to stay the same, and the minus 3 and the equal 0 are all going to stay the same. But this negative 11x is going to get broken up into a negative 12x and a positive 1x. Because by doing that, I can now factor by grouping. I can take a common factor out of each one of these pairs that's going to leave me with a binomial that's the same in both groups. So taking a 4x out here, I'm left with x minus 3, and taking out just a 1 here, because these two don't have anything larger in common, I'm also left with an x minus 3. Now I can take these two terms and combine them together, since the x minus 3 and the x minus 3 is the common factor among those two terms. That leaves me with a factored polynomial of 4x plus 4 and x minus 3. Now it meets the criteria for the zero factor theorem, and I can set each one of my pieces equal to 0 and solve for x. So here I'll get an x equals 3, and on this side an x equals negative 1/4 by moving that 1 over to the other side and then dividing by 4. In this next problem, I need to do just a tiny bit of rearranging to get it equal to 0, just moving that 30 to the other side. So I'll have a 6x squared plus 57x minus 30 equals 0. And I'm noticing that all of these coefficients have a 3 in them that I could take out. So I'm going to always, when you're factoring, if there's a greatest common factor you can remove from all of your terms, you want to do that before you start factoring the rest. So when I take the 3 out, I'm left with the quadratic 2x squared plus 19x minus 10 equals 0. Using Stephanie's handy x, I multiply my two leading coefficients. Notice it's the number coming with the x, not that 3 that I took out. So I'm looking for factors of negative 20 that will add to 19. Well, if I take a positive 20 and a negative 1, and multiply them together, they will give me negative 20, and if I add them together, they'll give me positive 19. So remember, these are not the new numbers that go into your binomials. These are just the numbers that are going to split that middle term. So the 3 stays on the outside, 2x squared stays the same, minus 10 stays the same, and all I'm doing is splitting up that plus 19x into a plus 20x and a minus 1x. Then I factor the polynomial. Out of this first term, I can get a common term of 2x, which is going to leave me with an x plus 10. And out of this next one, negative 1x and negative 10, the only thing those two have in common is the negative. So I'm going to go ahead and factor out a negative 1. And that will leave me with an x plus 10 on the inside. And that was also done intentionally so that these two terms will match each other, x plus 10, x plus 10. Now that they match, I can factor that out and be left with 3 times 2x minus 1 times x plus 10, all equals 0. Phew! Finally, I have factors, no adding, no subtracting, just factors, and they are all equal to 0. Well, there is no way to get that 3 to be a 0. So in order for the zero factor theorem to work, one of these two terms are the things that are going to have to turn into a 0. So this one, degree 2, even though it's got 3 factors, is only going to have 2 answers because my x was only to a power of 2. So when I solve the 2x minus 1 for x, I get x equals 1/2. And the x plus 10 for x, I get x equals negative 10.